Okay, now we are going to look at law of averages. This tells you actually what happens to the average when you increase the sample size. That's what generally talks about. But the book gives you some examples and so. So let's look at one example done by this person John. He tossed a coin 10,000 times. Uh, so at he recorded, so then it can record, for example, he is interested in the number of heads here. So he can record it, and if you get a head as a 1, otherwise 0. Right? So this is again a Burnley trial. Right. So at each trial, you can look at the total number of heads up to that point. That will be equal to the number of ones up that point. So sum of your outcomes will be equal to the total number. If you divide that by n, that will be the proportion of heads. Right. So if you toss now, supposing this is a fair coin, if you toss a coin n times, what is the expected number of heads in n tosses generally? N divided by 2. Right? So that's what for the expected number. Right? So the actual number of total number of heads, let us denote it by, for example, Tn. Tn is the total number of heads up to the nth trial. Let me denote by the proportion of heads, that is Tn divided by n as Pn. So if you repeat this experiment again and again and again, tossing the coin large number of times, at each time you can calculate T1, T2, T3, T4, T5, each one you can observe. So if you toss 6 times, you expect about 3, right? Yes. So in that case, you say the error in our observation is, it's not really a error in the sense that it's a mistake or something, but the difference between the observed number, for example, total number, minus the expected number at that point is called the error in that case. And similarly, if you toss a coin, say, uh, 50 times, you expect 25 to be the expected number of heads. What is the proportion of heads you expect? If you proportion of heads will be the same always, right? Proportion will be 0.5. Right? So we can talk about the error of the proportion also. Error of the proportion will be Pn minus 0.5. So what this person has done is actually he has looked at the error. Error in the total. Error, as I mentioned, is not in the sense that it is a mistake or something. It's just the word that they use for the difference between the actual value that they have observed minus the expected. So they have looked at what happens to the error when n is increased. So they have the numbers like this, some numbers. So for example, when n is equal to 10, they have observed 4 heads. So expected number is 5. In that case, the error will be difference is equal to 4 minus 5 is minus 1. At 20 trials, he had observed 10. So expected number is also 10. Therefore, there is no error in this case, 0 like that. So these are the errors. So they have plotted the errors versus the n. Like I equal to make a scale. This scale is not in the correct length. For example, 10 to 100 is this distance, and then 100 to 1000 meters is distance. So forgetting about the scale, they have just drawn to show what happens actually. Right? So general, this is for the TN. So you can see that TN was at the beginning was not that varied, but towards n, towards large values, TN can be large also. Right? So the error in the total number of heads can be growing large. Uh, but if you look at the error in the proportion, it's the other way around. Error in the proportion becomes zero, right? Expected observed proportion is equal to Tn divided by n. Observed proportion is 0.5. So if you look at the difference between that, that's going to be close to zero when you go increase n. So that's what we mean by now here. If you look at the proportion is actually an average here. Average of what? Right? If you consider these ones and zeros, if you add all these numbers, you get the number of ones. If you divide it by n, you get the proportion. On the other hand, it is just the sum of the numbers divided by n, which is called the average. So the proportion can be considered as an average of these zeros and ones. And you can see that the average error is close to zero. Average error of the average error of the mean becomes zero. Average error of the total doesn't go to zero. It can be large when n is large. So the idea that the average error becomes zero. In other words, in this particular experiment, the average proportion expected the observed proportion is getting close and close to the observed proportion. In other words, the error in the proportion becomes zero is what you call the law of averages. Right? Law of averages. So in general, we can say the average value, average of our observations become close to the population mean. Then we that is the population mean is the same as the expected proportion. Right? Observed proportion is the varying thing. Expected proportion is the population proportion. That is what we expect as the proportion if you do this very large number of times. So what is happening is that the observed proportion is converging to the expected proportion as n goes to infinity. In this case, proportion can be interpreted as average also. So in that case, therefore say observed average is converging to expected average. So that's, but that is his data. So I also generated some data by just considering some Bernoulli trials with probability point equal to 5. Right? So I was generating ones and zeros. And here in one experiment, I did it 10,000 times using my computer. So this was my graph for the error in the total. Right? So error in the total was very large here. This was very close like that. But here, error in the proportion, in that case also getting close to zero. I did it again, and in that case, this was the behavior of the error of the total, error in the total. This was the behavior in the proportion. Right? So the error in the total can be quite large sometimes in standard variable, but the proportion is behaving the same way always. Right? It's close to zero. The error in the proportion. Right? So there is another 10,000 runs. They are again error in the total can be quite large also, but here error in the proportion is always coming to zero. So that's what this phenomenon is one that we call the law of large numbers. Observed mean, in this case mean is a proportion of zeros and ones, but in general it can be some other values also. We will look at some other examples. In this case, ones and zeros. So when you have ones and zeros as your data, proportion of ones is the same as the mean of values. So mean is coming to the expected mean in this case. Expected mean is 0.5. Therefore, the error is becoming close to 0. So now let's look at a different situation rather than ones and zeros, just to see the same phenomenon happens if you consider some other experiment. Let's consider drawing from this box. You have 1, 2, 3, 4, 5, 6. Consider drawing tickets one by one with replacement from this box. So with replacement. At each time, you will be looking at the total of numbers you received up to that point. Total of numbers you received up to that point. So that is denoted by Tn. And also I will look at some, one variable I will be looking at is Tn, the other variable is the average by the time of n rows, that is x bar n, right? So there will be a T1 at that point, x bar is the same as Tn. When you have two observations, you have T2, that is the total of the first two observations. You can also calculate the average of those two observations, that is x bar 2. When you have three observations, you have T3. Average of those three will be denoted as x bar 3, like that. You can look at both series, what is happening to Tn and what is happening to Xn. Now, if you consider the total at some nth point, nth experiment, what would you expect as, what is the expected total?
3.
Huh?
3.
No, because you are doing this n times now. So therefore the expected total will be not 3 times n. Okay. In one, you have the average 3. So you are expecting each time it to be on average 3. Therefore, at the end step, expected total will be 3 times n. Expected x bar n මේකේ 3 නෙවෙයි මෙතන කීයද මෙතන සම් එක ගත්තාම මේකේ කීයක් නේද ඔක්කොම දාලා 1 to 6 ආය අපේ ඉසිලි වැඩි කිසි මාත විදීම දෙකෙන් එන්න ඕනේ කේන්ද්‍ර 6 දක්වා ගත්තා 21
තුනයි සම්පා
තුනයි සම්පා දාගෙන එතකොට so in that case 3.5 times n will be the total, average will be 3.5. 3. So therefore the error in Tn will be equal to Tn minus 3.5 times n. That is the error that if you look at. The other one, the error will be x bar n minus 3.5. So 5 will be the average every time. So you have to divide this by n, this therefore is 3.5. Right. So when I did it again by simulations, this is what I got. So the average, when you take the difference will be coming to close to 0 here. But difference it can be very large. Like this is 0, it can be quite far away from 0, the total. So that is one again 10,000 values. And this is another scenario. The error in total can be quite large, varying very much. But here error in average becoming close to 0. And similar to this one. So that's what we mean by actually the law of averages. The more common word for this one is actually law of large numbers. Many people call it law of large numbers, but I think law of average is more meaningful than law of averages. So because what you are looking at is what happens to the average as n goes to infinity. Right? So therefore we can say that x bar this average of the numbers, average of our sample converges to the population mean. Right? Population mean was 3.5 in those numbers 1 to 6. You consider 1 to 6 that box as the population. Population mean is equal to 3.5. So you can see that x bar n converges to 3.5. Therefore, the error converges to 0. So that's what we mean by the law of averages. So what is the use of this? Use of this is actually, so if you are, for example, interested in estimating the population mean, right? So we know that according to the law of averages, if you have a large sample, then h bar n with that large sample, it will be very close to the population mean, and therefore that will be a good estimate. So that is the main use actually. Law of average confirms that your estimate will be a good estimate for the population mean if you have a large sample. That is the general use of it. So if you look at again the previous Jones experiment, what we were looking at is Pn. We saw that Pn was converging to 0.5. The error in Pn was the proportion was converging to 0. That is again a law of average because Pn is actually an x bar n. Pn is the mean of those zeros and ones. So that is again a law of average. Okay, now in the book they're talking about box model right now. Sometimes we are interested in answering questions. Actually, in the next chapter, we will be talking about now. Here we are just saying it's going to be close to mu, but of course, the error can be different. For example, at the beginning, error can be somewhat large, and then when n is around 10,000, it's becoming very, very close to 0. But in most practical situations, we may not have as large as 10,000 sample sizes. So if you have a fairly reasonable sample size like 50 or maybe even 10, there will be an error in the difference. There will be an error that is a difference between the actual x bar and the actual population mean. So how large that error can be is a question. We will be talking about the measure of the size of the error in the next chapter. But we can get some idea about the discrepancies between the expected value and the observed value in a lot of problems like in games and so. If you use a box model, right, like in the previous problem, we were assuming that we were sampling from a box of numbers. Right? We looked at what will be the error of the total. So there are problems where we can look at our particular problem, we are interested in a quantity. We can model the quantity that we are interested in as the total of some of the draws when we are drawing from a box. Right? For example, when you are playing a game, you are interested in how much is the total gain that you get, right? How much you are earning. Right? So at each game, if you are playing a game, a card game or some other game again and again and again, you are betting again and again and again, maybe on the same number, the same amount. How much would you expect to gain after 100 games or 50 games and so on? So you can answer that kind of questions using the same idea. Right? You're looking at the total of gain and what's happening to that and so on. So in order to understand that, the book considers this making a box model. Right. So let's look at this particular game called roulette wheel game. I had to learn about that also because I didn't know that. Right. So I actually looked at some pictures also. So it says Nevada roulette wheel has 38 pockets. It's a wheel one is numbered 0 and then another numbered 00. So those are two different ones. And then 1 to 36, all the others are marked as 1 to 36. So this person who plays this, I don't know how to pronounce that, croupier or something. The croupier spins the wheel and throws a ball onto the wheel. Right? I have seen that in videos and so on. The ball is equally likely to land in any one of the 38 pockets. Before it lands, the people can bet, okay, where it's going to land. Right? So this is the roulette wheel. 38 places for the ball to come. 1 to 36 and a 0 and double 0. And so people can bet on the board here. Right? So there are different types of bets. For example, you can bet on the color. You can say you are going to bet the ball is going to land on a black one or a red one. There are reds and blacks. Or you can say ball is going to be within the first 12, right? Or you can say ball is going to be within the second 12, right? Like that. Different types of bets are possible, and the amount paid for each type of bets is in the book, right? And if you bet on the color, you are going to get if you win, you are going to get the same amount. If you bet a $1, then you are going to get a $1. Otherwise, you will lose that $1. Right? So that 1 to 1, even like that. Different types of bets. Right? So there are sometimes if you bet on a 1, for example, on a single number, if you say, okay, it's going to land on 6, and if it exactly lands on 6, then you get, for $1, you get $35, 1 to 35. So that is one type of, and another one is called, I don't know, split covers, 17 to 1. So that means if you bet $1, then you get 17 if you win, like that, different types. All right. So let's look at this particular example. So we want to now look at the net gain of a player, if assuming that the player is going to bet on the same, do the same bet, right? Make the same bet, same type of bet, again and again and again, and see how much is the possible total gain after large number of games. Right. So let's look at this particular one. Suppose the person is betting on red or black. So betting on the color in that case. So in that case, there are except these 0 and double 0 ones are green. The other ones are red or black. Right. So this 0 is green, double 0 is green. All the others are black and red. So except for 0, 0 and 0, all which are colored green, these ones are green, the numbers on the roulette wheel alternate red and black. If you bet on a dollar on a red, say, and the red number comes up, you get the dollar back together with another dollar. That means you are earning $1. If a black or a green number comes up, the croupier smiles and takes in $1. Right? So in that case, you lose your $1 and he takes that dollar. Right? Suppose you have just put a dollar on red, right? Bet on a red, and the croupier spins the wheel. But suppose you play a roulette 10 times, not 1 times, betting $1 on each time. What is likely to happen there? You will end up ahead or behind some amount. This amount is called the net gain, right? So you start with $1, you always bet $1. Sometimes you may end up with a negative value, or maybe end up with some positive value. So net gain is how much you got. The next net gain can be positive. Is positive if you come out ahead. Otherwise, it's negative. Right. So my question is now, our question is, what is likely to be, what kind of values are possible as the net gain if you play the game 10 times, each time betting $1, on the same color, on the red. Right. So if I want to look at these possibilities, I can frame this problem as a drawing from a box. Right. So what kind of box do we have? What are the numbers I have in the box? And how many times should I take? What is my sample size? Right. So what numbers should be going into the box to decide the gain? Right. So this we have to model our problem as a drawing from a box. Now in this case, what are the possibilities? Either you win $1 or lose $1, right? So therefore, the box should have plus ones and negative ones. How many is the question, right? So that depends on the probabilities. So you are taking with this with replacement from the box. So what is the probability of in one game? What is the probability of having a win, like getting a positive one?
17 out of 36.
Yeah, altogether 38.
38 or 30.
No, 36. Ne? They got people
Yeah.
read the 36 in half.
But 2 of 3.
They got in a negative positive win, red win, 36 only they got. 38 only 36 only they got. තමයි red ඒවා තියෙන්නේ. කියන්නේ 18 තමයි red ඒවා තියෙන්නේ out of 38.
Red ඒවා black ඒවායි සමාන නැහැ.
red ඒවායි black ඒවායි සමානයි. ඒකෝට red ඒවා black ඒවායි 36 තියෙනවා ඔක්කොම. අර දෙකත් එක 38.
එනයිටි.
එතකොට red ඒවා තියෙන්නේ 18 නේ. එතකොට 18 තියෙන්න ඕනේ plus ones box එකේ. ඊට පස්සේ 20 තියෙන්න ඕනේ negative ones. Right, so you have to have a box. Right. So plus ones 18 තියෙන්න ඕනේ, negative ones තියෙන්න ඕනේ 20. Right. So if you take now 10 rows with replacement from this box, that will tell you what are the possibilities. Right. At the end, what is total gain. Right. You cannot say exactly you are going to get this amount, that's a random quantity. So just to get some idea, right? So this is what you mean by making the box model, right? So you have to decide what are the values that you should have in the box, right? So there should be 18 pluses and 20 negative ones, plus ones and negative ones. And then how many of each, right? And then how many rows you have to have, 10 rows. So I did that using a computer. This is what I got. So these several times I did it. So each time either it goes up or goes one by down, one down or one up. So there are less number of positive ones. There are more numbers. Therefore, there is a higher, less chance of going up. Generally, more chance of going down. But you cannot see that from these few simulations. But that is the real situation. So, for example, here going down consecutively and then coming up and then like that. So what can you see that in this case I am looking at again the error, right? The expected error. No, this is actually the total gain. No, this is zero totally. Yeah, around zero. So this is actually the error that they are making. So error is going to be
The net gain. It is going to be net gain, right?
That's right, because we expect after one game, what can be the average error? Positive one or negative one? So therefore zero. So the total expected gain is going to be zero always, right? Because පොඩ්ඩක් ධනාගයක් තමයි ඍණාගයක් තමයි බලාපොරොත්තු වෙන්නේ average gain එකට. Average gain because negative one never තියෙනවා 20 possibilities. We have 20 possibilities for negative one. 18 possibilities for plus. So average එක විදු වෙන්නේ average එක පොඩ ඍණාගය. ඒක තමයි පිටුරේ පේන්නේ බලමු පිටුරේ වැඩිපුර තියෙන්නේ කොයිද කියලා දාන දෙයක්. අරගේ දාන දෙයක්. මේ ටිකේදී බලදී 8යි වලදී ඔය වගේම බැලුවොත් එහෙම 1000 විතර වැඩිපුර ඒවයි පේන්න ඕනේ නෙගටිව් පැත්ත ඉතුරු. That's what we expect. Average gain to be at the end negative. Even if the game will not positive, we don't miss that. That's why these people are having casinos too. Otherwise, people will not conduct casinos, right? Because they are expect to win always, right? But there's some chance that players win also. But on average, casino people are winning. So here also, therefore, there's a little bit higher chance for them to win. So make on that and other මේ මනුස්සයා වාසනාවන්තයි වගේ. බීබුවට ඇවිල්ලා තියෙනවා පොඩ්ඩක් පොසිටිව් එකක්. එතන බීබුවේ නැවතිලා තියෙන්නේ. පැරදිලා තියෙන අවස්ථා දෙකේ විතරයි. 10ක් ඔය වගේ ප්ලේ කරොත් 8ක් ප්ලේ කරොත්. Right. Okay, let's look at another problem just to make a box. There is a different type of bet. If you bet $1 on a single number, on another bindu what line එක අදින ගෙදේ මන්නේ අර ඉස්සෙල්ලා අඳපු graph එකේ new program එකම තියෙන එක වෙනස් කරනවා කියලා බින්දුව ගාලා ගෑලා තියෙන average එකේ කොට ගාලා තිබුණේ චුට්ටක් average එක ගත්තා නම් negative එක තමයි line එක. If you bet $1 on a single number at Nevada roulette, you bet on $1 on a single number at again හරියටම number එක කිව්වොත් color එක ඉස්සෙල්ලා දැන් number එක and the number comes up, you get $1 back together with 35. So that means your gain will be $35. If you got another number comes up, you lose the dollar. The dollar can nothing now either everything here but and the gain again negative again. Gamblers say that single number pays 35 to 1. So that's how they mention it. 35 to 1. Suppose you play roulette 100 times, betting $1 on the number 17 each time. A single number on 17 each time. Your net gain is like sum of how many draws from what kind of box. It's going to be like 100 draws, but your net gain will be the sum of 100 draws. What's going to be the box look like?
minus 136. Minus 136.
35 එකක් තියෙන ඉතින් gain එක 35 වෙන්නත් පුළුවන්. එහෙම නැත්නම් negative එක 1 වෙන්නත් පුළුවන්. ඒක තියෙන්න පුළුවන් tickets වර්ග දෙකයි තියෙන්න පුළුවන්. එක 35 එහෙම නැත්නම් negative. කීයකේ තියෙන්න ඕනද? ඒ box එකෙන් තමයි ගන්න. එතකොට 35 වෙන්න පුළුවන් chance තියෙන්නේ. එකයි. අයි 17 නේ 17. ඒතර අනිත් ඔක්කොම මේ රිනියු 37 තියෙන්න ඕනේ negative ones box. ඒතර box එකේ තියෙන්න ඕනේ 135 and 38 වලින් අනිත් ටික ඔක්කොම negative ones in box එකෙන් තමයි අපි ගන්න. ඒතර මේ box එකෙන් 100 times ගත්තාම ලැබෙන එක එකතුව තමයි අපේ gain එක. Chance of winning is 35. So දිනුවොත් එකපාරට උඩට යනවා 35 ප්‍රමාණය. පැහැදුනොත් එක එක තමයි බලන්නේ. So let's look at the possibilities. Now, so මේක තමයි වෙන්නේ. මේකෙන් පේනවා අපිට බලපුවම මොකක්ද දැන් කරන්නේ. Because there's a high chance of getting negative one. එක දිගට එන්න පුළුවන් පල්ලහැට යන එක වෙනවා. ඉන්නේ ඒව එක දිගට එන්න ලොකු chance එකක් තියෙනවා. So very rarely you get a 35 එක පාට 35 යනවා. So මෙතන දැන් 35 යනවා. මෙතන ඊට මෙතන ඇවිල්ලා සෑන් එකට ඇවිල්ලා 35 පාට. So දිගට negative one side. So like that, these are some possibilities. මෙතන බලුවොත් බලමු ධන 1, 2, 3 out of these 8 cases. And it's okay, but we don't think in if you want to find out how many, what is the probability of winning or probability of losing at the end, calculate formulas, or we can do this thing large number of times because of you can find out roughly what is the probability of winning, getting the positive gain if you play 100 times. So definitely that will be a very small probability. Right? There will be a large probability of losing. Right. Okay, actually that's the end.